Okay, we're back, and we're in writing equations of lines part 2. I have a little editing issue there. Sorry about that sloppiness. And in writing equations of lines part 2, we're going to talk about writing the equation of the line in slope-intercept form. So our final answer looks like y equals mx plus b in 3 forms. First, given the point-slope form, so this is a review from part 1. Then, given a point and a slope, and then also given 2 points. And we have a secret guest star with us today. More to come. Okay, so for our first example of writing equations using the point-slope form, here is our point-slope form, y minus y1 equals the slope, m, times x minus x1. And our first example is y minus 5 equals negative 9 times x plus 3. So go ahead, press pause now, get this into your notes. Okay, welcome back. Now the first thing we want to do is remind you to draw your little arcs, which reminds us to distribute, and then we're basically just going to copy the rest. So y minus 5, because I didn't touch that, equals negative 9 times x is negative 9x, and a negative 9 times a positive 3 is a negative 27. Now that we've distributed, we're going to use inverse operations to get y by itself, right? We're going to isolate that variable, solving in terms of y, and we get y is equal to, this cancels out, negative 9x comes down, and a negative 27 plus a 5 is a negative 22. And that's our final answer. That is in slope-intercept form. Just a quick reminder, what we did at the beginning is we distributed the negative 9, and then we solved in terms of y by adding 5 to both sides to get y by itself.
Okay, we are going to do a second example, as shown here on the screen. I'm going to first do the distributive property. What I did now was I took the negative 3/5 in front of the parentheses, and I distributed it to the x, and I also distributed it to the negative 5. And notice that the denominator of the 5, of the 3/5, go cross cancels with the integer negative 5. Consequently, I get positive 3. Now we are going to undo the minus 2 on the left side of the equation by adding 2 underneath the number and adding 2 under the 3. Add the negative 2 and the positive 2, they're opposites, they drop out, and write the balance of your equation and add the 3 and the 2 to make a positive 5. Your equation is now in the form of slope-intercept.
So now we're going to move on to a second example, right? Write the equation given a point and the slope. So again, we're going to stick with this point-slope formula, but this time it's just not going to be filled out for us. All right, so what we have at this point, we have some given material. We have been given a slope and we've been given a point. So now what we're going to do is take this given information and substitute it in the proper locations, okay? So as we rewrite, we got to rewrite carefully. Y minus, and here is my y1 value. So that's y minus a negative 4. Be careful, that minus sign in the formula is not the negative for the 4, okay? M is going to be negative 5, our slope is given as negative 5, times x minus our x sub 1, so that's 3. Now we're right back to where we just started. Carefully dealing with my double sign on the left side, y minus a negative 4 is y equals plus 4. So y plus 4 equals negative 5. I'm going to distribute negative 5x plus, because I got that negative times a negative, 15. Last thing we're going to do, isolate y by using the inverse of what I see. Subtract 4 on both sides, I get y is equal to negative 5x plus 11. That is in slope-intercept form, so that is the equation of our line. We're all set. Next example. All right, so here we are for our second example, and all the first step is we're just going to substitute in our given information into our point-slope formula carefully. So y minus, and our y1 and x1 are right here, so y minus 4 equals our given slope of 1/3 times x minus 6. Now the point here is to carefully distribute, so I'm just going to rewrite the left side as is. Y minus 4 equals 1/3 times x is 1/3 x. And then off to the side here, 1/3 times a negative 6. The 3 cancels out that 6, making it a negative 2. So it's just 1/3 x minus 2. Last step we're going to do, isolate y by adding 4 to both sides, and we get y is equal to 1/3 x plus 2. And again, that's in point slope-intercept form, so we're all set. All right, for our next example, we're going to be writing an equation given 2 points. So the first thing is to realize that we're very close to our last example. The only thing is we don't have the slope given to us, but we have an ability to get the slope. So at this point, what I've done is I've labeled my points, as you should, and I got my slope formula right here. And now I'm just going to substitute these values into this formula, as you should already know how to do. This is old school. And calculate the slope. So go ahead, press pause, and take care of that on your own. Okay, well, I don't know about you, but I got a slope of negative 2. So now we have the same situation. Pick one of the points. I'm going to choose 3, 2, because there's no negatives in there. I'm going to try to keep my world easier. So now we have our given point and a given slope. So I'm going to substitute that into our point slope formula. Y minus my x sub 1, which is, or my y sub 1, which is 2, equals slope negative 2 times my x minus x sub 1, which is 3. And then I'm going to distribute. So very carefully, y minus 2 equals negative 2x plus 6. I'm going to isolate y using my inverse operations. And for a final answer, I'm going to get y is equal to negative 2x plus 8. And that's our final equation. Okay, so now we have another example here. Negative 5, negative 6 is one given point, and 0, negative 3 is another given point. So first we're going to want to go ahead and calculate our slope. So why don't you go ahead and calculate slope on your own. Press pause. Come back and check in with me. Okay, I ended up with 3 over 5. So let's just take a quick look here. I have negative 3 minus a negative 6, which turns into a negative 3 plus 6. And I have 0 minus a negative 5, which is 0 plus 5. And so when it all shakes out, that becomes a 3/5. So now again, I have my given slope and a given point. And the point I'm going to use, I would prefer to use the 0, negative 3, because it's easier than using 2 negatives. So let's substitute that into our point slope formula. And as you can see, this is going to work out fairly easily. First, I want to put my arcs in to remind myself to distribute. And now I'm going to get rid of these double signs. That's going to be y plus 3 equals 3/5 x. And I could put a minus 0 here, but that's kind of a waste of our ink and time. Now let's remember that I just said that's a waste of our time and our ink and time.
Yeah.
Minus 3 and minus 3 on both sides is solved for y. And I get y is equal to 3/5 x minus 3. And that about wraps up the show. So let's just recap what just went down. All right, what we should be able to do is write equations of lines in the slope-intercept form, given the point-slope formula, all filled in, given a point and a slope, or given 2 points. And just as a reminder at the end, if you were to end up with slope equals 0, then remember you're going to have a horizontal line and an equation of y equals some numerical value. For example, y equals negative 3 might be a final answer. And then if you have a slope that's equal to undefined, then remember your final answer is going to be x equals some number. An example of that might be x equals positive 5, and remember that's a vertical line. Good luck. See you next time.